In this video, I'll introduce the idea of molar mass and how to utilize dimensional analysis to solve kind of the beginner type molar mass questions. So here we have two of those questions. The first is asking for the number of moles of carbon dioxide in 10 grams of carbon dioxide. And the second is asking for the number of grams of sodium chloride in a given mole of sodium chloride. So in the first question, we're trying to get from grams to moles. And in the second question, we're trying to get from moles to grams. So when you're dealing with this interconversion between grams to moles or moles to grams, we utilize something called the molar mass. Molar mass. And it's indicated by this M-type symbol. Now what the molar mass is for a given substance, the molar mass of that substance is the number of grams needed to make 1 mole of that substance. Now I know that's not at all very complicated, but I promise it'll make sense once it's in writing. So if I were to give you a substance, it's essentially the number of grams of a substance needed to make 1 mole of that substance. Okay. Now you would kind of wonder, how do I calculate the molar mass? Is there a special formula? Well, it's actually a lot easier than you think, and it really relates to how you found atomic mass. Okay. Now, if I were to ask you for the atomic mass of carbon dioxide, then you would say, oh, that's an easy one. I know that carbon is 12.011 AMU, and that each oxygen is 16 AMU, but there are 2 of them, so I'd have to account for both of them. And I just add them up, and that gives me 44.011 AMU. That is the atomic mass of carbon dioxide. Well, if I were to ask you for the molar mass of carbon dioxide, it would actually be the very same number. It's the same answer, except for the fact that the units are no longer in AMU. They are now in grams. So, what does that mean? What does it mean that the units of atomic mass of molar mass actually are in grams per mole. So what does that mean? That means that if I have 1 mole of carbon dioxide, meaning I have 6.02 times 10 to the 23 molecules of carbon dioxide, then it will be equivalent to 44.011 grams. So 44.011 grams of carbon dioxide makes 1 mole of carbon dioxide. Okay, so that's essentially what molar mass is. So it's calculated the same way as atomic mass, and it's the number of grams of a substance needed to make 1 mole of that substance. So now we're going to apply it to these 2 problems, and I'll also introduce dimensional analysis and how we use that to solve these problems. So let's start with problem A. How many moles of carbon dioxide are in 10 grams of carbon dioxide? So the way I like to solve these problems is by writing down the given first. So we're given 10.00 grams of carbon dioxide. And then I make these little boxes, well, essentially boxes. And the diagonal boxes, as you'll see, so going from here to here, they will consist of the same units. So if I have grams here, then I will have grams here. And then units will change as I go from here to here. Okay? And that's when I want to make the changes to the units such that I can find what I want to find. So let's start. So I know I have 10 grams of carbon dioxide. And if I have grams here, then I'll have grams down here. And I essentially want to get to moles of carbon dioxide. So that's where my unit will switch. Okay? Now, how do I get from grams to moles? Well, using the molar mass, of course. So we know that 44.011 grams of carbon dioxide make 1 mole of carbon dioxide. So that's how we get from grams to moles. And then after you get to this step, you just multiply across on top in the numerator and in the denominator, and then you divide the bottom from the top. Okay, so I have 10 divided by 44.011, and let me put that into the calculator, and I get 0.2272, and the units is in moles of CO2. And the units is in moles because that was my last unit in the dimensional analysis. Okay, so how many moles of CO2 in 10 grams of CO2? 0.2272 moles. Okay, so 10 grams of CO2 make up 0.2272 moles of CO2. Okay, now for B, so this was A, now I'm going to go on B. I have given 0.905 moles of sodium chloride. 0.905 moles of NaCl. Okay, and I want to get to grams of NaCl. And if I have moles here, then I'm going to have moles down here. Okay, so how do I get from moles to grams or grams to moles? I use the molar mass, right? So let me blow this up for you, just enough for you to see, and calculate the molar mass of NaCl. Well, I know NaCl is Na plus Cl, right? So I know Na is 22.99, and I know Cl is 35.45. So let me just add those up, and I get 58.44 grams per mole, meaning that for 1 mole of sodium chloride, it will constitute of 58.44 grams of sodium chloride. Okay, then I multiply across, so 0.905 times 58.44, that gives me, rounding to sig figs, it gives me 52.9 grams of NaCl. So that's how you use dimensional analysis to solve these sorts of questions. You have a given, and diagonally you keep the same unit, and then you try to change that unit towards the one that you desire. Now, not all questions will be this straightforward, and as we go further, we'll see that there will be more steps involved with this process. If you guys have any questions on this, feel free to comment, and I'll see you next time.